Have you ever sent an email and just wondered how it zips across the entire globe in like a split second? Well, I can tell you it's not magic, but it is an absolutely incredible journey. Today, we're going to follow a single piece of your data and uncover the secrets of how the internet actually works. Let's dive in.
You know the drill, right? You type out a message, you click that send button, and bam! Moments later, it arrives on a screen halfway across the world. It really does feel instantaneous, almost like magic. But what's actually happening in those milliseconds? What incredible path does your message take to get there?
Okay, so it's not magic, but it is this highly organized, ridiculously fast process that all happens in layers. Seriously, think of it like a super efficient assembly line. Your data gets prepared, it gets packaged, it gets addressed, and then it's shipped out in a bunch of distinct, logical steps. And today, we're going to follow an email through that entire process. So, our journey begins the very moment you hit send. But before your email can even think about traveling, it has to be prepared for the trick. And all that prep work, it happens in the top layers of our networking model.
First up, the application layer. Now, this is the part you actually see and interact with. Your Gmail, your web browser, you name it. It uses these special rules of the road, which we call protocols, like SMTP for email, to get your message ready to go. You can think of it as the starting line for the whole race.
Right after that, we hit the presentation layer. This thing is like the internet's universal translator and its security guard all rolled into one. It makes sure your data is in a format that literally any computer can understand. And, super importantly, it encrypts your message, scrambling it up so no one can snoop on it, and then it compresses it to make it smaller and faster to send.
And then we have the session layer. Its whole job is to open up a direct line of communication, or a session, with the computer on the other end. It's kind of like picking up the phone and waiting for someone to say hello before you start talking. It opens the line, keeps the conversation stable, and hangs up when you're all done.
All right, so our email is prepped and ready and the line is open. But how do we make sure the entire message gets there in one piece, safe and sound? Well, that's where the next layer comes in. Welcome to the packaging department.
This is the transport layer, and it's basically the internet's postal service. What it does is brilliant. It chops your big email into a bunch of smaller, numbered pieces called segments. Why? Well, if one tiny piece gets lost along the way, we only have to resend that one little segment, not the whole thing. It also adds a port number, which is like putting an apartment number on a letter. It tells the receiving computer exactly which app, like the email app, this data is for.
Now, a really important decision gets made here. Do we use TCP or UDP? For our email, we need it to be absolutely perfect, so we're going to use TCP. Think of it like certified mail. It checks for delivery, it makes sure everything arrives in order, the whole deal. Now, if you're on a video call, you might use UDP. It's way faster, like sending a postcard. A few pixels might get dropped, but speed is what really matters.
Okay, our message is now in a bunch of neat little packages. But how in the world do those packages know where to go? They need an address and they need a map. Let's move down to the next layer to see how they get one.
And that is the job of the network layer, the internet's global GPS. It takes our segments and wraps them up into something called packets. And here's the crucial part. It stamps each packet with the source and destination IP addresses. You can think of an IP address as the full unique street address for any computer anywhere in the world.
So yeah, this layer is all about finding the best route. It looks at that destination IP address, and like a master navigator, it charts the most efficient path for that packet to take through the internet's incredibly complex web of networks.
So the packet has its global address. It knows which country, which city, which street to go to. But how does it get from your computer to your local router? You know, the on-ramp to that huge internet highway?
That's where the data link layer jumps in. This is the local mail carrier. It takes that IP packet and puts it inside yet another wrapper called a frame. This frame contains the MAC address, which is a unique hardware ID for your device, of your computer and your local router. This is all for just getting it from one device to the next on your home network.
This is the world your computer's network card and your home router live in. Devices called switches act like smart traffic cops here. They use those MAC addresses to send your data directly to your router instead of just shouting it out to every single device connected to your Wi-Fi.
And finally, we've reached the bottom, the physical layer. This is where it all gets real. That frame, packed with all our data, gets converted into a stream of ones and zeros, bits, and then into actual physical signals. We're talking electrical pulses down an Ethernet cable, radio waves for Wi-Fi, or little pulses of light for fiber optics. The journey literally begins now.
After traveling across who knows how many routers and networks, our signal finally arrives at its destination. And now, the entire process we just watched happens in reverse. It is time to unwrap the package.
So, the whole thing just goes backwards. The physical layer grabs those signals and turns them back into data. The data link and network layers check the local and global addresses, then they just peel off their wrappers. The transport layer gets all those little segments and reassembles them in the right order. And finally, the upper layers decrypt and format the data, delivering your original email perfectly to the recipient's inbox. It's a perfect reversal. Now, this whole layered process, it seems incredibly complex, right? But it's all based on this really brilliant conceptual framework. So let's zoom out for a second and look at the blueprint that makes all of this possible. The journey we just followed is basically described by something called the 7-layer OSI model. It's not a physical thing. It's a universal standard, a conceptual guide. It lets engineers create new technology for just one layer without having to worry about breaking all the others. It's the rulebook for how everything should fit together. Now, while that 7-layer OSI model is fantastic for understanding all the concepts, the real-world internet actually uses a more streamlined version called the TCP/IP model. As you can see, it kind of combines some of the layers, but the core functions, especially that transport and internet layer, they're still right there. It's just a more practical take on the same brilliant idea. And that right there is the absolute genius of this whole design. This modular, layered approach is what allows the internet to be so unbelievably powerful. It means you can innovate on one layer, like creating a faster Wi-Fi standard, without having to reinvent the entire system from scratch. It's what makes the internet both incredibly robust and endlessly adaptable. So there you have it, from a single click to a globe-spanning journey in milliseconds. The internet's layered design has been the unsung hero of our digital world. It's a system that has scaled beautifully, connecting billions of us. But you have to wonder, as our world gets even more connected, even more data-hungry, will this design hold up forever, or is it maybe time for a new blueprint? That's a question for another day. Thanks for joining me on this incredible journey.